Okay, I see the numbers starting to slow down. So I just want to welcome everyone to the first in our series of events celebrating the 50th anniversary of the Clean Water Act. I think it's appropriate to say its trials, its tribulations, its successes, its challenges. I'm joined on today's panel by staff scientist Mike Doan and our guest, Dr. Curtis Bohlen, who I don't often call doctor, but who certainly has earned the distinction. He's the director of the Casco Bay Estuary Partnership. Some of you may know, but it's always great to look at history since we're celebrating the 50th anniversary of the Clean Water Act, that Friends of Casco Bay started in response to a report in the late 1980s about all the pollution in Casco Bay and the threats to the bay. And one of the first things that this Friends organization did was petition under Section 320 of the Clean Water Act to have Casco Bay designated an estuary of national significance. And it was so designated. It's one of 28 in the country, and that is what created the Casco Bay Estuary Partnership. And so since then, we have worked very closely together to improve and protect the environmental health of Casco Bay and its watershed. I'm sure Curtis can tell you a little bit more about that or get the details right. So we're very grateful for Curtis's many skills. He's an expert in the field. He's an expert at policy. But what we're really grateful for today is the expertise and time he put into taking years of data collected in all different ways, in all different methods, with all different equipment, and trying to smooth that out and put it together into a comprehensive report. You're going to see the tip of the iceberg today of that presentation. You'll see the much more that went into it. He'll show you some of the other subjects, and we'll make sure you have a way to access that, and you'll have time to ask the questions at the end. But without further ado, I'd like to turn it over to Curtis. We have plenty of time for his presentation and a discussion afterwards. So Mike and I will go off screen. Curtis, please share your screen, and see you afterwards.
Okay, I hope that's showing up. All right, great. Well, thank you, Ivy, for welcoming me, and welcome everybody. It's great to be here. I think Ivy didn't say one important thing about the long-running relationship between our two organizations, and that is we have complementary roles and complementary things we try to do, and we try to work very closely together as a long-term partnership, doing things that each organization is better suited for. We are stronger together, and it's a very, very important part of our network as the Estuary Partnership to be working with friends all the time. So with that, let me dive in. I'm going to focus on our State of the Bay report, which came out last December. If I can get the advancing thing to advance properly. There we go. I wanted to start by just reminding you that the Casco Bay Estuary Partnership is one of 28, only 28 national estuary programs around the country. And we are actually all created by a portion of the Clean Water Act. We were created by Section 320 of the Clean Water Act, which was part of the amendments to the Clean Water Act that passed in late 1980s. And so we're actually also approaching, we're regularly approaching dates of importance for us as well in terms of anniversaries. The 30th year of the National Estuary Programs went by a couple of years ago. Our 30th year went by, and pretty soon the 30th year of being in what we consider doing the good work for Casco Bay comes up in another couple of years. So we have, as Estuary Program has that timing issue as well, thinking about these anniversaries. Our role, as distinct from what the Friends does, is we try really hard to be a community working on behalf of Casco Bay. So yeah, we have a staff at USM with 4 of us on the permanent staff, but the real magic of the Estuary Partnership is that we are a partnership, and therefore we have many different folks who are part of the network, and that network is the heart of what we try to do. We act as a clearinghouse for information about the Bay. The State of the Bay report is a big piece of that. And we try to bring people together to build consensus, coordinate work, build understanding, and act generally as a bridge between science and policymakers to try to improve how things are done regionally and what kinds of policies are implemented. To give you an idea of what the scope of the State of the Bay report was, there were 19 chapters divided roughly into 3 categories. One is drivers and stressors, what's going on that's affecting the bay effectively. The second is the condition of the bay, or how's it doing? And the third is human connections. Why do we care? And so those 19 chapters I'm only going to touch the very surface of these. I'm going to not even get into a couple of different areas at all, because it's just too much to cover in a brief talk. I want to remind you all of the area we're talking about. Casco Bay is a big and complex bay, especially when I compare it to some of the other National Estuary Program watersheds and National Estuary Program bays. The watershed is about 980 square miles. The bay itself is about 160 square miles of water, depending on exactly where you put the outer border. We've got something on the order of 575 miles of shoreline, and about 785 islets and ledges that are there at mid-tide. I put about because it really depends on what you count as an island. We've got 13 coastal municipalities and 48 towns total that touch the Casco Bay watershed. So there's a lot of complexity from a biological, physical point of view, and a lot of complexity from a political and social point of view. One of the important things to realize is that unlike some of the other National Estuary Program estuaries, our system is pretty heavily marine dominated. Tides are a really big deal. And tidal exchange is usually a lot bigger than in and out of fresh water in any given day. In order to pull together this State of the Bay report, we actually looked at about 110 different data sources and tried to decide if we could figure out how to use them and how to fit them into the State of the Bay report. We ended up using about 45 of them in detail. Those were provided by, my last count was at least 25 organizations. This all gets a little squishy around the edges because it depends what you mean by an information source. But we got at least 25 different organizations that contributed data towards State of the Bay. And we tried very hard to follow what is a growing idea in coastal science these days and aquatic science, which is to make our data and our data analysis online following a concept which is called open science. So actually, almost all of our data and our detailed data analysis code is available for external review or for people to use secondarily. And we've had a couple of college and university classes make use of the data, which is kind of a cool little add-on extra for making this data available. The bottom line I want you all to walk away with is that conditions in Casco Bay continue to be better than in most similarly sized estuaries in the US Northeast. And a lot of that has to do with our particular geography. Our largely forested watershed helps reduce pollutant loading to the bay, and our strong tides help protect water quality by moving things around fast. But we do see the bay is changing and has changed, and we see some persistent warning signs that we get anxious about from time to time. And I've seen what I think of as some emerging themes that come out across many of those 19 different chapters. And I'll start diving into some of those right away. The first thing I want to highlight, especially because we're talking about the Clean Water Act, is that our water quality investments do appear to be paying off in Casco Bay. And actually, we see signs that some of the national and state level regulatory programs are also paying off in terms of improved water quality and improved aquatic habitat conditions. So I want to start with one that's mostly about investments, and that's combined sewer overflows. For those of you who don't know what this is, most of the sewers in the northeastern United States were built actually before they had wastewater treatment plants to go to. They just got the sewage and often the stormwater as well and took it all down to the ocean and dumped it in. Once we built wastewater treatment plants, we still only had one set of pipes for taking sewage and stormwater runoff and rainfall derived waters from our neighborhoods to the ocean. And what happens now is under a big rain event, there's too much water coming through those systems for them to carry all that water, and they overflow into the bay in a number of different places. And so we're effectively on big rain events dumping untreated sewage into the bay. What's amazing to see is that over the last 20 some odd years, the volume of discharges, which is very closely related to rainfall. More rainfall means more overflow, but the total volume of discharges has dropped over that 20 some odd year period substantially by on the order of almost 50 million gallons of discharge per year on average over that long period of time. And that's in spite of the fact that rainfall has over that period, if anything, gone up. And this represents big investments by our communities in wastewater control and in stormwater control and combined sewer, what's called separation. The big hole in the ground next to 295 that I'm sure you all drive by from time to time is an example of some of the community investments going into making this happen. We also, from a sort of another direction, sort of thinking about other things that are improving that reflect larger scale controls in the region. We can look at a number of toxic contaminants in the bay, and we can look at this locally. And here I'm looking specifically at toxic contaminants in blue mussels, data collected by Maine DEP. And those toxic contaminants at 3 locations where we have a long enough record to trace anything, we can see that what are called polycyclic aromatic hydrocarbons have been declining over the last, again, 15 to 20 year period. And most of that probably reflects tighter controls of automobile emissions. So this is not a Clean Water Act control, but it is regulatory controls that are benefiting Casco Bay through other kinds of regulatory machinery that addresses environmental concerns. I'm going to change directions a little bit and talk about an issue that was highlighted by friends of Casco Bay for years, and that was incorporated into our priorities and back in 2016 as a priority to focus on, where we've really had a fabulous relationship with friends, with Maine DEP, with the Portland Water District, and many other partners in looking at nutrient pollution in the bay over the last 5 to 7 years, and we've learned a tremendous amount. And I've got both good news and bad news. The good news is that when we look at Friends of Casco Bay's data, where they have long-term nitrogen data at 5 locations around the bay, nitrogen concentrations are declining at 3 of those 5 locations. They're actually declining at all 5, but at the 2 that I didn't put lines on here, they don't meet what are considered standard statistical significance criteria. So declines are happening everywhere, but we know they're meaningful at least 3 of those 5 locations. It's not entirely clear what's driving that decline, but there are some hints at what might be causing it. One of them is a call out that I want to make to Portland Water District, which has worked very, very hard over the last few years to reduce their nitrogen discharges. They updated their aeration system at the East End Wastewater Treatment Plant back in 2017, and they're now able to manage that plant to optimize removal of nitrogen, at least during the warmer summer seasons and warmer months of the year. And they've dropped summer discharges of nitrogen by something on the order of 3/4 every year since then, which is a pretty remarkable achievement. And I think we are seeing that not only in nitrogen concentrations in the bay, but I think we're seeing it also in some of the data we have now on epiphytes growing on eelgrass and the health of eelgrass communities in and around that East End facility. The second discharge is maybe the second decline in nitrogen entering the bay is perhaps a reflection also of automobile emission standards and changes over the last period of time. We see this throughout the Northeast. There's a monitoring station up at Wolf's Neck in Freeport where they measure nitrogen discharge, nitrogen being deposited to the surface of a sampler. And you can extrapolate that to look at how much nitrogen that implies is entering Casco Bay or per unit area, as I've shown it on the graph here. And over the last, again, 20 some odd years, you can see a significant decline from something on the order of 3.5 to almost 4 kilograms per hectare of nitrogen in the early portion of that record, down to over the last 10 years, down to about 2.5 kilograms per hectare of nitrogen. And that probably, again, reflects automobile emissions reductions as people have purchased newer cars that have lower emissions than their older counterparts did. But in spite of those declines, we still see that throughout the bay where we've got good nitrogen data, we do see occasional high nitrogen events. How often they happen varies from place to place, but they happen pretty much everywhere. So let me start with the map on the left-hand side here. This is showing the median total nitrogen observations at each of these monitored locations over the last period of 10 years or so. And the highlight here is that we see certain areas of the bay with very high nitrogen concentrations, and they tend to be these areas in the upper estuaries. So at the head of the Fore River, at the head of the Presumpscot River estuary, up in the Royal River and the Cousins River estuary, at the head of the Harrisicot estuary, and over here up at the head of the New Meadows. So these are all areas with restricted water movement, and they're areas where the mixing of fresh water and salt water probably affects how nitrogen moves around in those waters and gives us these locations with the very high numbers. We can look at the graphic on the right and see that as compared with thresholds that DEP has used for what they call reasonable potential analysis, which is essentially a way of saying how much nitrogen is safe in these waters. The level of 0.32 milligrams per liter of nitrogen is designed to protect eelgrass, and the higher level at 0.45 is to avoid low dissolved oxygen problems in the waters. And we can see that certain portions of the bay, like the Royal River estuary, we get values above those thresholds quite frequently. While as in other areas, including the inner bay and the outer bay offshore, we very, very seldom see numbers that exceed those values, but we do see them. They occur, and they occur periodically. So what that tells us is nitrogen levels are high, and they're something to keep an eye on and to be concerned about. They don't necessarily tell us exactly how to address that yet. The third theme for us is really identifying the importance of location. And I'm going to highlight two things to talk about location. One is the role of the bay's hydrodynamics and understanding what's going on in terms of water quality. And the other is thinking about urbanization and its effect on conditions in the bay. This is a graphic showing temperature, the median summer water temperatures of sampling locations in Friends of Casco Bay's water quality monitoring program. And the darker colors show water that is cooler, and the lighter colors show waters that are warmer. The distinction here is that where we have lots of cooler temperatures, those darker dots, that reflects a lot of mixing with offshore cold waters, while as inland waters, especially fresh waters coming into our estuaries, bring warmer waters. And you see these warmer water sites at the head of the Presumpscot, at the head of the Royal River, and at the upper Harrisicot, and up in the New Meadows, where again, we have those isolated waters, and especially waters with freshwater inflows. And it turns out that's a very good predictor of water quality conditions. Friends of Casco Bay has been collecting data at many, many locations around the bay, and it becomes hard to figure out how to summarize what they see. What we've done is we've graphed them here in order by those median summer water temperatures. So the sites with the coolest water are on the left hand of the graph, and the sites with the warmest water are on the right side of each graph. And these are all ordered exactly the same way. And what you can see is cool water, offshore waters, we have high dissolved oxygen. Cool waters in the mouth of Portland Harbor, we have moderately high dissolved oxygen. As we get to warmer waters and we move towards the Harrisicot, the Fore River, upper Fore River, and other more estuary sites, we see lower dissolved oxygen, and we also see lower Secchi depth. For those of you who are not familiar with Secchi depth, this is a measure of water clarity, where you drop a roughly dinner plate sized disc over the side of a boat and see how far down you can see it. And in offshore waters of Casco Bay, you can see that plate down 3 or 4 meters. And when you get into some of our estuaries, it gets harder and harder to see. Similar patterns occur with salinity, where our offshore waters have high salinity, where we have rivers coming in at the upper end of our estuaries. You see these drops of salinity, and guess what they're related to? They're often related to changes in pH. So the hydrodynamics, water flowing in, water flowing out, fresh water coming in, mixing with salt water, and the processes that the tides give us really explain a lot about what we see for water quality patterns around the bay. And that helps us understand where we might be concerned about elevated nitrogen conditions or other kinds of water pollutants. We can look at a different pollutant or a different risk and look at bacteria around the bay. And this shows another kind of pattern. This relates more to urbanization than it does to those hydrodynamic patterns. The darker dots here are showing levels with relatively high concentrations of bacteria, and the yellower dots show relatively low ones. And while we can see there are some areas on the eastern and northern bay where we have higher levels of bacteria in the water, the highest levels consistently tend to turn up in our suburban shorelines. And I'll point out we have no data along the urban waterfronts because Maine's Department of Marine Resources doesn't bother to sample for bacteria there because it's not legal to harvest shellfish there for other reasons. So we just don't have data there. What we see here is a connection to urbanization. The more urban the lands are, the higher the bacterial loads in the water tend to be. It's truly remarkable that we have 2 swimming beaches right in the heart of that urban area, and both of them are open to swimming most of the time, which is a pretty neat accomplishment in and of itself. Oh, wrong way, sorry. Another connection to urbanization is looking at pesticides. The Maine Board of Pesticide Control sampled intertidal sediments around Casco Bay at each of these green dots. And what I did is basically looked at underneath each of those green dots and counted up how much asphalt there was in each of those circles. And we can look at the relationship between the amount of asphalt under one of those green dots and relate it to the concentrations of one particular pesticide, bifenthrin, that was measured in those intertidal sediments. And what we see is a really tight relationship. There are a few exceptions. We don't know why Yarmouth's value in 2014 was so high, but it was. And there's some sites where we didn't observe enough to be sure whether it was above detection limits or not. We don't know whether there was anything measured there, anything present or not. But in general, we can see a very strong relationship between the degree of urbanization as measured by the amount of asphalt within that 500-meter circle around a sampling location and the concentration of this particular pesticide in the sediments. The only reason we only report on that one that one pesticide, is because it's the one that was easiest for the Board of Pesticide Control to detect using the particular laboratory analyses they were using. It doesn't mean there aren't other pesticides that wouldn't show a similar pattern. We just don't know because we weren't able to detect them all. And we can see a similar pattern looking at other toxic contaminants. And here it's a little bit trickier because I've got different names on the bottom. Our most urban sites for these contaminants in blue mussels are the East End and Spring Point sites. And then we get increasingly less urbanized as we look at Mill Creek, Navy Pier, and Mare Brook at the other end of the bay. And there's a tight relationship with polycyclic aromatic hydrocarbons with the highest levels present in our most urbanized sites and our lowest levels as we get further away from Portland and the Portland end of the bay. And for polychlorinated biphenyls, a group of toxic chemicals that are from a variety of different sources, we see the same pattern. They're more abundant in the urban environments and less so as we go towards more rural environments. So urbanization has a clear impact on conditions in the bay as well. And I'm going to very quickly, I want to highlight, we also looked at climate change. Climate change has changed. Climate has changed and we see effects in the bay. The first thing is temperature. We do see warmer temperatures overall, especially warmer winters. The signal in the summer is actually not very detectable against background noise yet, but in the winter, it's very clear our winters are getting warmer. We're having fewer and fewer cold days. And one of the consequences is that our growing season now is about a month longer than it was back in the mid 20th century. So it's really quite a big change in terms of overall growing season length. We see that in the bay. Friends of Casco Bay's data shows that water temperatures have been rising all in the spring, summer, and fall, which are the seasons when we have long-term record from them. And it's been rising by about 0.5 degree centigrade every 10 years over the roughly 30 years of this data record. We also see changes in precipitation, which are probably quite important for the bay because more rainfall probably means running more pollutant off the land into the bay. And we're seeing total annual precipitation has gone up by something on the order of 10 inches over the last 50 or 60 years. So we're getting closer to 45 or 50 inches of rainfall now. We used to get 35 to 40. We see more days of heavy precipitation. In particular, days with more than 2 inches of rain have gone from about 1 a year to about 3 a year. And days with about 1 inch of rain have gone from about 8 a year to about 13 a year over the past, again, 60 years or so. So the record here shows a very clear trend at Portland Jetport in increasing precipitation as well as increasing temperatures. We also see rising seas. The sea level rise for Casco Bay is actually pretty close to the global sea level rise average. But when you take a relatively small 7 or 8 inch increase in sea level over 100 years and look at it in terms of flood frequencies, what we see is very rare floods due to high tides and high tide events back in the 1920s, having about once a year in the 20s and 30s, now occur about 8 or 9 times a year. And with relatively simple simulation models, we can jump up to saying what would happen if we increase sea level rise by about a foot. And we see that so-called blue sky flooding basically due to tidal dynamics and a little bit related to local wind conditions, but blue sky flooding should be happening on the order of about 60 times a year, 60 days a year, which roughly means every 2 weeks, we're going to see 2 days of flooding on those spring tides, on the highest tides of the 2 to 4 week period. So flooding is going to be a much more common event, even if it's not much deeper in the future. So that gives you a brief outline of a few of the things we looked at State of Casco Bay. The wedges in yellow highlight the things that I touched on today, and the other ones are things I didn't talk about at all. And there's of course much more online, much more available for you to look at if you want to look at more detail at other topics. But takes a gotta be selective to fit it in within 20 minutes. So with that, I think we're back to conversations.
Thank you so much, Curtis. And Mike, thanks for coming on camera. Before we get to the questions from our guests, I wonder, Curtis and Mike, what do you think has been the biggest success for Casco Bay of the Clean Water Act so far? Curtis?
You know, I always think that we forget some of the parts of the Clean Water Act that are probably most important. And one of the ones that I think I would point to is construction of wastewater treatment plants. Back in the early days of the Clean Water Act, the state revolving loan fund provided a huge bump up in funding for construction of that infrastructure that we forget how important it is, not just the wastewater treatment plant, but the plumbing to get the waste to the treatment plants and all the rest of it. And that goes back to the early days of the Clean Water Act, and now the state revolving funds still exist and can help with upgrades. But we tend to forget that. We think about it as being a regulatory program, but the funding avenue, I think, has been probably even more consequential.
Thank you. Mike?
Yeah, absolutely. I have to agree with Curtis. Those improvements or the building of those sewage treatment plants is so important. You can still see the ruins of some of the wooden troughs in Portland Harbor where sewage used to run from the roads and down into the bay directly. And it's such a big deal. I really can't imagine a Casco Bay without those sewage treatment plants, the protection those plants offer. So absolutely agree.
Excellent. Well, I know that the sort of piggyback on that, the Clean Water Act, it provided this money, but then it also set up this regulatory system with permits that issue every 5 years. And so it's been a great way to every 5 years evaluate the science, look at what new things we're learning about. I saw some people commenting in chat about PFAS. We've talked about nutrients, and look at ways through the Clean Water Act and the every 5-year permit cycle that treatment plants can do even more. And I think the nitrogen removal is a really nice sign of that. So that's a great big success, but where has the Clean Water Act failed us or not yet helped us achieve success? Curtis?
Yeah, I think about this in terms of what people were thinking about and how people conceptualized water quality problems back when the Clean Water Act was passed. And the focus on the logic then was that our big problem was big pipes. And we haven't done as well addressing other kinds of threats to water quality. And in particular, I think of urbanization and its secondary effects on water quality. We haven't really figured out how to have an urban landscape that doesn't cause water quality problems downstream. And those are much more difficult, more diffuse problems, and more challenging to address. And habitat values, there's pieces in there of the Clean Water Act that can address habitat values, but it's not front and center for how most of the regulatory programs think of themselves, if you will.
Okay, so in a nutshell, what you're saying is the Clean Water Act has done a really good job with pollution that's coming out of a pipe, both from industrial sources and treatment plants, and reducing that. But then some of these more diffuse sources, like from urbanization, it's not quite there yet. Mike, what do you think?
I think, I hate to say failure because it's been such a success story through the years, but 50 years ago, we may have failed to see how much damage humans could do to the environment. So with things like climate change, it really hasn't taken, of course, it couldn't have taken that into account. And as Curtis mentioned, with climate change, we're going to see more frequent storms, more wet weather events, more severe storms, bringing more stormwater, more pollutants to the bay. So I think that rather than look at it as a failure, there's a lot of places we can certainly update to make it more in touch with the things we're dealing with now. And including those emerging pollutants like PFAS, as well as climate change.
Yeah, I think in listening to the two of you, I mean, the Clean Water Act, it was never intended to be everything. And it's sort of like a dual system, right? The federal government regulates pollutants and the states set water quality standards and classify water bodies. And then there's so many other regulations that control what happens in our coastal areas, down to municipal zoning and ordinances and state stormwater rules and regulations. And so it seems like with what you're talking about, the Clean Water Act is a great tool, but then we need to complement it with other tools that are more localized. And one of the wonderful things that happened last session was the legislature passed the sea level resolve, which puts into all state coastal land use laws where it's needed, uniform projections of sea level rise, and then also asks the state to update all of its coastal land use laws to take into account increased storm surge and more precipitation and sea level rise. And as part of that, revising the state stormwater rules. So hopefully we can all work collaboratively on this, but these are really big, difficult problems. And it's hard to kind of like undo what the harm that's already been done. How do we get at what we've already done to the landscape? You know, we can maybe do a better job moving forward, but it'll definitely be a challenge. Mike, before we turn to the audience questions, you brought up climate change, and we all spend a lot of time working on climate change and thinking of that as threat number one. Curtis, can we address climate change through the Clean Water Act? Easy question, yes or no?
Yeah, right. It's a good question. I think the structure of much of the permitting rules under the Clean Water Act focuses on this idea of pollutants. It's not clear from a water perspective what we call a pollutant in all these issues. Even coastal acidification, we can talk about, is pH a pollutant? You start to trip over some really complicated things where it's not obvious that the Clean Water Act is lined up to help us with that. I'm sure there will be ways to be more clever and ways to incorporate the risks we see growing because of climate change through the other permitting programs. But as a direct avenue, I don't see an easy path.
Yeah.
But you're the lawyer, come on.
Yeah.
Oh, I get to ask the questions right now. Mike, I saw you shaking your head. So are you agreeing with Curtis? Anything to
Absolutely. Add? Yeah, I can't top that from there. It's really hard to see how the Clean Water Act might work against climate change, but we could always be updating water quality standards to look at things like pH perhaps. But there's so many different layers of challenges, I think, now with climate change.
I think you mentioned an important point, Mike, and I see Fred just added WOTUS, which means the definition of waters of the United States. That's a very important way how we define that, and defining it as broadly as possible so that we can be as protective as possible of our waters makes a difference. And that's a federal battle going on right now. And that's why sometimes we have to do our work on a federal level to protect our local Casco Bay. Mike, I think you brought up a really good point. I don't think it'll be easy, but will there come a time when we have enough science that we can set ocean and coastal acidification criteria as part of our water quality standards, or adjust the temperature range for thermal discharges now that our waters are warmer, or look at the pH range and do that? And it's going to be a lot of work and very technical and kind of hard to do because the conditions keep changing. So, you know, the three of us can keep talking about this all day, but there's actually other people who want to talk with us. And I'm going to start with a question that there's a tension where urbanization is correlated with the degradation of water quality, but higher density land use is associated with greater benefits for climate. How do we ensure that the land use changes we need to make in our area make our area less resilient on automobiles, do not degrade water quality in Casco Bay? I'm not sure that this got down right. How do we ensure that the land use changes we need to make, or how, I'm not sure if this came quite right, but I think the question's trying to ask about urbanization and how to make our areas less resilient on automobiles and with denser cluster voting, so the development. So
I think it's an excellent question, and it points to this tension of it's very clear that protecting our forests is one of the best things we can do to protect Casco Bay. And we have to protect the forests, we have to work around ways to minimize new development, which means putting more people into existing developed landscapes rather than developing new areas. And so there's clearly, if we're seeing these water quality consequences of urbanization, there's a tension between protecting the bay because we protect forest and protecting the bay because we don't want the pollutants associated with urbanization. I think the question is very well poised and points to a fundamental challenge. Is there a solution to that? I don't know. In that, I think this gets to be a question of how well do you manage to do your site development and how well do you manage the pollutants coming off the urban landscape? And as I mentioned, the reductions in automobile emissions is a helpful thing for a lot of the pollutants coming off urban landscapes. But we're going to shift from petroleum-powered vehicles to electric-powered vehicles that will get rid of some of our pollutants and not others. So, it's going to be an interesting question to see how that evolves over time.
Especially as more and more people move into this area, as the greater Portland area grows in popularity.
Yeah, the municipalities, many of the municipalities in the greater Portland area are working on a model ordinance right now to require the use of low impact development techniques that I hope helps really protect the natural hydrology of the sites and to restore some of the past harm as sites are redeveloped. So I hope that helps as well. I'm going to jump around and ask a science question. And are you able to see any changes in nutrient availability during anadromous fish runs?
It's a great question. We did not have that data available for the State of the Bay report because we are relying on historical data that we were able to dig up. I know of at least two studies that have been done actually by students here at USM over the last year or so that have been looking at that question. One up in the Penobscot River, so not local, but showed definite nitrogen transport from the marine environment up into freshwater systems. In that case, an area where the alewives were concentrated below a dam, so it wasn't getting up into a lake; it was getting into an area where they couldn't go anywhere. And then looking at alewife transport of nutrients into and out of Highland Lake here in the Casco Bay watershed. Some students have done some nice work demonstrating with some modeling that it looks like the net flow of nutrients is probably more out of the lakes than in. So we don't see them specifically in Casco Bay. I wouldn't expect to see changes in nutrient availability unless we had a spot where those fish are trapped in large numbers, like they saw at the upper end of the Penobscot estuary.
Right.
So, where they can't move, I think we might see it, but I don't know of anybody who's looked locally.
So before I ask Mike the same question, the question asked about nutrient availability. Are the students or these studies tracking both nitrogen and phosphorus?
I don't remember the details. These are presentations I saw for master's degree students finishing up their projects. So the work's been going on, and they have to be thinking about both to some extent, and I just don't remember what the details of each of the studies was. One of them was stable isotope work, so probably nitrogen focused.
Okay. Mike, any?
Not much to add. It's we certainly haven't been doing that work, but I know as we start to push our monitoring, further upstream, maybe that's something to consider moving forward.
Okay, the next question I think has already been answered. We are definitely seeing bay temperature trends going up. So I'm going to skip to what is the typical reason the pesticide, this is that pesticide, Curtis, I don't know, the
Oh, the
first
bifenthrin?
slide that you showed, why is that pesticide being used near asphalt?
The
So
bifenthrin.
I'm
Yes.
sorry, this is me being too blithe in my discussion. I didn't explain that clearly, so thank you for the question. It's not that it's being used near asphalt, it's that we are seeing it near asphalt. And asphalt functions in this case as a surrogate for the degree of urbanization of the landscape nearby. So presumably those pesticides are being used in the urban landscape in one way or another, and we don't know exactly, or I don't know exactly, what uses would make them being used at those locations. But pesticides don't stay where we put them; they move around. And so, what's happening here is we're seeing that they are found in those environments, presumably because they're used more near areas with more asphalt, because that's where more of the people are. That's where more of that particular pesticide is used. I mean, it's very different for different pesticides. Not every pesticide has the same usage profile. This one happens to be one that is relatively safe for mammals, and so gets used a lot in places where people or animals might be exposed. Rather different from a pesticide that would be used more in an agricultural landscape, for example. So, each pesticide has its own profile. But that particular one, as I said, was the one that we could detect at lowest concentrations and therefore had some information.
Okay, Mike?
And actually, if I could, before I get to that, go back to the temperature question, because I just want
Yes,
to
sure.
reinforce that. It is important. We absolutely are seeing warmer waters in Casco Bay. And Curtis showed that graph with the data from spring, summer, and fall, still showing a significant uptick in water temperatures. But it is even more obvious with the winter data, which we're collecting now with our continuous stations. So
My
in
bad, I
this
could not have
slide,
skipped
even
over
without
that.
the winter data, it's still going up. So it's even more pronounced with the winter data included. But
Okay,
just to make sure that's reinforced, that we answer that. And I agree. It's just you've got more asphalt, more runoff as well, bringing those pollutants, those pesticides down into the water.
excellent. We have another pesticide question, and then I have a follow-up question. So the next pesticide question is, how do you explain the high pesticide content in the area around Chebeague and Long Islands? There appears to be a lot of tidal flow in that area.
I actually don't have an answer for that. I mean, again, what that particular graphic is about is specifically about where we saw it, and the particular analysis didn't look specifically at hydrodynamics. So I don't have a good answer for whether water movement would change it. I don't have a good answer for specifically what the local uses are. My guess is that it may have to do with some of the things we raised about water movement. And it may be that being anywhere close to Portland, that my surrogate of local imperviousness may be a surrogate for being close to major stormwater outfalls, or maybe a surrogate for other major discharges, or maybe, I mean, we don't really know how it got to each of those locations. And we don't know how far it is transported from when it first enters the bay. So one of the reasons why those samples were done throughout the bay was to try to get some sense of whether distance mattered. And we couldn't pull that out of the sample. There just wasn't enough information. But we could look at this general land use relationship. So it's a really good question, and I don't have a good answer.
Yeah.
Mike?
No, well said. Can't top that.
The question that came to my mind, Curtis, was I was looking at your trend in the connection to urbanized environments, and Curtis also sits on the board of pesticide control. For those of you who don't know all the many hats he wears, but South Portland was at the very high end, and that sampling was taken in 2014, and South Portland has now passed two very good ordinances, a pesticide ordinance and a fertilizer ordinance. Does the Board of Pesticide Control have any intention of going back to monitor as those ordinances go into effect to actually see the reduction?
I will highlight that Fred Dillon posted a link to a more updated report from the board, which was not available when I did the State of the Bay report. But that it's slightly different sampling design and things like that. But in general, the problem with any of these pesticide things is that sample analysis is very expensive to analyze for these pesticides. So no, I think the general answer is, well, we would all love to get back and do it. Saying there is a concrete plan, there are so many conflicting needs for where we want to understand where pesticides are in the state of Maine and how they move around, that I don't think the focus is largely on, let's go back and do it again because it would be cool to know. It's more, well, what are the bigger issues we need to nail down more precisely? So I wouldn't be surprised if something like that does happen someday, but I'm unaware of any sort of strategic plan that has it included in.
Right.
Mike, anything to add?
No, I just want to make sure we don't miss the obvious answer that some of these pesticides may be being used on those islands as well as the
Yes.
dynamics involved.
That's what I was wondering too, where it was in
point that
relation
out,
to the land uses on the island that could
Yeah.
could be contributing pesticides.
Yeah.
I think that is, have you figured out what is causing the losses of eelgrass in Casco Bay?
And it's even better to get a question for something I didn't show slides on.
Yes, that was going to be my last question.
We did look at eelgrass in a fair amount of detail, and this is a fabulous program now where we're getting aerial photography every 5 years to get really good, accurate numbers on how much eelgrass there is. And there was a huge decline in eelgrass just before the 2013 sampling. And it's thought to be that was largely caused by disturbance by the boom of green crabs that happened at the same time. What makes that particularly interesting to me from a climate change perspective is that boom itself is probably caused by warm winter water temperatures, which Mike was just talking about. The green crabs, historically, population has been limited in part by winter mortality, and a couple of warm winters in 2012 and 13 meant we had very, very large populations for a couple of years. And that led to significant destruction of eelgrass at the time. About half of those losses had recovered by 2018, this next round of sampling that we had available before this. And we will see, again, there's another round of sampling coming up, and we will learn in that round whether that trend of recovery has continued or not.
Mike?
There are also some water quality threats around the southern end of the bay, but they don't seem to be causing the huge losses that the green crabs caused. So,
Mike, do you want to add anything?
Nope, that's good. Oh.
I'm going to add something, you know that. So I think the other two threats that we see, and it's localized, is that where nitrogen levels are high, it negatively impacts eelgrass health. So it doesn't necessarily make it disappear, but it makes it a lot less healthy, and the beds are thin and they're covered by epiphytes or other like plants and things that live on plants. And so that that's an issue, and that is part of what Curtis had mentioned. Well, what are we going to do about the nitrogen problem? And the state, the Department of Environmental Protection, has a stakeholder group convened right now that all three of us serve on, that's looking at all the nitrogen data in the greater Portland Harbor and trying to determine threshold levels that can be set that will protect eelgrass and other water quality, prevent other water quality issues as well. So that's one other negative consequence to eelgrass. And then the third thing that we're seeing, which sometimes is controversial to mention, but is that some of the bait fishing, if the fishermen are not careful or don't know where the eelgrass beds are, perhaps because they've rebounded and didn't used to be in certain areas, when they put their nets in the water, they can really cut down the eelgrass beds. And then you see a lot of the eelgrass wash up on shore. And I can distinctly remember that from a few years ago. I know Dan is on this call, and I can't remember if it was McCoy or Middle Bay, but I do remember seeing that up there a lot. And then there were questions about that last summer as well, where we saw a lot of eelgrass drift on the beach. So I think that those are other causes of concern with eelgrass. And then the threat that we haven't really defined yet is sea level rise and rising temperatures in the near shore. And I know eelgrass has a comfort range in terms of temperature, and I don't know if eelgrasses that are further south, I don't know if they'll migrate it. I don't know the answers to all of this. I'm like looking, now I'm getting nervous because this is a Curtis's area of expertise, but these are like other threats that we have to think about with respect to eelgrass, because it is like such a critical habitat and so important for our coast to be resilient. So it is more than green crabs. What's hard about green crabs is like there's not a whole lot we can do about them. These other issues we can do things about. And so I think we're focused more on that.
Eelgrass certainly has a depth as well, like
Yes,
below.
that's
So
what I was saying with
level
sea
rise
level
continues,
rise, like where can it migrate? Like,
less habitat declines.
yeah,
And with more
so
aspects, it's going to have a hard time moving inland.
yeah. So Curtis, we're getting closer to the end, and one of the things that I wondered is if you could have, what else would you have wanted to share with this audience from State of the Bay?
Oh, wow. The challenge, I think, for State of the Bay is that there are so many bits and pieces, and a big challenge for us is figuring out how do we present information in a way that communicates to a wide range of audiences. So it's hard to sort of figure out of all the different things in there. There are, to some extent, the overall flow and the connection across all the things is the biggest story, is that there's a huge amount of information being gathered, huge amounts of information that we're not responsible for gathering. All we're doing is creating a window for people to see it as the Estuary Partnership, and trying to find a way to summarize and present it. And we've actually, as I said earlier, we've actually gone so far as to try to make all that data publicly available, which is a new thing for us. I hope people find it useful. Other topics, I don't really know where to go. I mean, I could, for different audiences, I grab different topics. So,
okay.
Yeah.
Mike, any final questions that you want to raise?
I don't. No.
Okay. I have one more question then to wrap this up before we tell our guests next steps, and that is, Curtis, we have spent a lot of time talking about all of these different factors, and it's kind of a little mind blowing because they all influence one another. And I think the slide where you showed like, oh, if it's colder or warmer, you're going to see this different dissolved oxygen, the pH is going to change, blah, 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 blah. And we're also in a time when things are continuing to change. So even like what we learned today is going to be different than what we're going to know 5 years from now, and things are not static. So things continue to change. So we're always trying to do our best to predict, based on the best available information, how we can help our bay be healthy and resilient. Having said all that, knowing that we need to make predictions, can you talk a little bit about the work you hope to do this year to create a model that will help us with these predictions, or to put all of this together? It's something our audience might be interested in knowing, so that how we actually do this, how we make guesses that are not random.
that have some basis. Yeah.
Yeah.
One of the things that has been on the to-do list for Casco Bay for at least a decade, and probably longer than that, is to do a modern, updated, what's called the hydrodynamic model. And that's a model that would actually be tracking the movement of water. It's based on lots of complicated physics, and it produces huge quantities of results and information. One of the things that's happened for us as an estuary program is that we've been, we will be receiving additional funding through the infrastructure bills that passed Congress last fall. And one of the things we plan to invest in is finally getting a hydrodynamic model for Casco Bay at a relatively high resolution. We've got partners lined up who are willing to help us pull it together and will run it for us every day, producing a 5-day forecast of water movement before it happens, saying what they think will happen based on a weather model and a hydrodynamic model that are linked together. So it's actually, wind matters a lot in Casco Bay. And so they'll use weather to predict the future wind and look at that in terms of being able to predict weather on a day-by-day, the water movement on a day-by-day basis. We'll also be able to look back in time and ask questions like, well, let's say it's a really, really dry summer and something goes wrong at one of the wastewater treatment plants. Where will those pollutants go? And what do we need to worry about? Let's say there's another oil spill, and where will those pollutants get transported? So these hydrodynamic models both have sort of forecasting capabilities. They also have hindcasting, look back and look at particular circumstances and say, if conditions were as bad as possible, just how bad would they have been? And what would happen if something had gone slightly worse? So we're able to use this to look back and to look forward in terms of water quality management. But it also leads to, nowadays, with a climate change and sea level rise focus, we also are better able, now we'll be able to provide 5-day forecasts of likely severity of flooding along Portland Harbor, for example. So figuring out how we get that information plugged back in so that decision makers hear it is still an unanswered question, but at least we'll have the infrastructure in place to be able to use that model to address a variety of community needs.
Thank you, Curtis. Mike, it's sounding to me like a future Casco Bay Matters presentation to share the model with our audience and how good models.
That's way beyond my pay grade.
Yeah,
somebody who
good
really knows
models
the
and detailed
that.
models that have all of these layers you're talking about are very helpful. Sometimes simple models can be misleading or not contain all the data. So we're really grateful that that work is coming up. It's almost time to wrap up. So I just really want to thank everyone for joining us. In follow-up to today's presentation, you will receive an email that will have a link to the presentation, a link to the Estuary Partnership resources, and can even tell you how to get to the data if you're so inclined to really dig deep into it. And you'll also get information about the other events coming up in our Clean Water Act series, which includes some field trips this summer to see some sites and some experiments under the Clean Water Act that are pretty exciting. One of the events coming up this summer is a second nitrogen NAB. And we did this 5 years ago with your help, our wonderful volunteers and members. And through this whole nitrogen criteria process that we're working on, we realized that a second NAB would be really useful. So that's coming up on August 7th. There'll be information on how to sign up. There is information on our web page for how to sign up. And we really hope as many of you will join us by land and by sea, by kayak, by sailboat, by lobster boat, whatever out there, to help us collect samples and create a second snapshot of nitrogen loading and nitrogen conditions in the greater harbor. So without further ado, right on time, I want to thank you all for spending part of this sunny day with us, and we hope to see you at all of our other events this summer. Thank you and goodbye.
Thank you.
Thanks, everybody.